Hello guys, welcome back to the Anime Curse. For this part we will carry on using loops as a data management tool. This time we will rebuild a topography point cloud from a text file which contains x, y and z coordinates of each point. This was created from a LAS file which contains Mount St. Helens topography. I converted it already into x, y, z coordinates in a text file. You can tell it's a very large file. Very large file. If I try to read this file in a single pass, I will crash Rhino for sure. So that's why I actually split text file into smaller parts. There's lots of online tools which actually are very useful to split text file by say 100 lines or 1000 lines or whatever you want. So let's get started. First off, let's go to Rhino. Okay, here we are. First off, we need to assign to file paths. Let's go to file path. Set multiple file paths. I'll go to the location of my text. I will assign all of these text files. I am not rating these files at the moment, I'm just assigning them. So let's set up our loop start, loop end. We'll need an additional input here. Let's make this connection. Make sure this is recording data. Okay, so data will be the file paths, which are this, and using the counter, I will rate a single file per iteration. So I need a list item. From all these files, we'll rate one of them. Now I can rate the file. We'll rate this file per line. Actually, I got all the lines of the very first text document I have. Next, what I need to do is to rate one row per iteration. In order to do so, I need to create a loop within this matrix loop. This technique is called nested loop, which means loops within loops. This is very useful and practical. So let's get started with this. First, we need to calculate list length, the number of rows I have in this file, so I can establish the number of iterations of my nested loop. Let's bring a new loop start and loop end component. Make sure this loop ends, the nested one. We right click, we record data, and also we output after the last. We want to avoid the matrix loop to be triggered by the nested loop, so we ensure like that it doesn't happen. We need to increase the number of inputs as well. Let's make this connection. Okay, so now we got the number of repeats. We need the button to trigger the loops. We will use the same button for both. Trigger. And the data will be the actually the data of the very first file. I will set a panel so we can actually visualize the current row, and also another panel to visualize current file using counter. I will leave him over here. Okay, after that I need to read one row per iteration. So from data I will read the one defined by the counter, and I will text split every row by a separator, which will be the comma. This will be useful to create the x, y and z coordinates per row. You can tell I got them already. List item. If I create a point using index 0, 1 and 2, x, y and z. There we go, I got the first point, which actually works now. After that we need to first introduce into the loop the coordinates at D1 and the current file data. Okay, there we go. I'm actually looping the very first file, which means it's working. But we need to ensure the matrix loop, the very big one, not the nested one, is not triggered by this looping. So I need to create an exit condition using larger than. If the counter is larger than the number of rows of the current file, we'll engage the loop until we achieve this condition. So let's introduce D1, which is the coordinates into D1 of the matrix loop, and data will be all the files actually. And there we go. We're not recording any data still from the matrix loop because we haven't finished looping the nested one. We will record until the nested one finishes. I will rebuild the point. For all of these X, Y, and Z. There we go. Actually, I finished looping the first file. I got all the points of the very first text file. We'll turn off everything else. If I add an iteration, it will keep looping and keep the latter point. As you can tell, I'm still regenerating all these points. I will leave this looping for the moment. Meanwhile, I will explain you how to establish the number of repeats of the matrix loop. We need to calculate the list length, as usual, the number of files minus 1. So this will be the total of files we need to read. Okay, so just let's leave it looping for about the half of the very first file. And there we go. Actually, we got all the points of the first file, and then we went to the next one, which is file index number 1. We can carry on doing this process many times if we want. We can actually define the real number of iterations we want with this process. List length minus 1. So that's it. This is a very easy and effective way of rebuilding geometries. Thank you all for watching and see you next time.